Okay, so this evening we are working through the Numeracy Intermediate Tier Paper 1 from November 2018, so from last autumn. We've already looked at grade boundaries and we've already filled in our additional formula that are going to be really helpful for us. So question 1. Fionn is making a box for a present. The box is a cuboid. Fionn draws a sketch of a net of the cuboid. Write down the height, length and width of the box. So, information there that is key. You need to know what a cuboid is. Well, a cuboid is a rectangular box shape. Okay, it's going to look something like this. But it's been laid out flat. It's a net. So it's been cut down the sides and laid out flat. So what will help you here is if you can imagine how that is going to be folded to turn it into this shape. When we did this in Reg a couple of weeks ago, what I suggested you do is to decide one of those to be your base. So if I say that's going to be the bottom of my box, then I'm going to fold this up and that's going to become the sides. So if that is the base, this distance is 6 centimeters. That's going to be 6 centimeters. If I fold this up to make an edge, the edges, the side edges, sorry, are going to be these two. So the height of this is going to be 4. So which just leaves me then the depth. Well, if that's my base, the depth or the width of it is going to be this shape, and that shape is going to be the same as that, which is going to come up. That's going to be the front, and that's going to be the top lid. So the width of this will be 5. So don't be afraid of trying to turn it into a 3D sketch to be clear what you're doing. So the height of this is 4, the length of this is 6, and the width of it is 5. After Fionn has finished making the box, she cuts and sticks coloured string along each edge of the finished box. The string costs 3 pence for every 2 centimetres. How much will Fionn spend on the string? Okay, so my answer is going to be in money, but I'm working with measurements. Now an edge is easier to see probably on the little sketch. The edges of your box are there. So my string is going to go around that 6 and that 6 and the 6 behind and the 6 behind and at the bottom. So I'm going to have 4 lots of 6, which is 24. I'm also going to have 4 vertical edges, which is 4 lots of 4. And in addition to that, I'm going to have 4 of these 5 centimeter edges. So the first thing I need to do is what the total length is of the string I need. Which is going to come to 60 centimeters. Now, the string costs 3 pence for every 2 centimeters. So if it was 3 pence for every centimeter, I'd need 60 lots of 3. But because it's every 2 centimeters, I'd need half as much. So it's going to be 3 lots of 30. So 3 pence for 2 centimeters. I will need 30 lots of 3 pence, which is 90p. Now, I'll be honest with you, when I was looking at this question myself, I didn't read that line. I just saw 3 pence per centimetre. So it's very, very easy to make mistakes when you don't completely read the question, because I couldn't work out when I looked at the mark scheme then where 90 came from, because I had 180. So you need to be super careful. Right, so where are the marks for that? Well, there's 1 mark for all of those right. There's a method mark for working out your total length of string, and an answer mark for 60 centimetres. There's a method mark for finding 3 pence times the correct amount, and an answer mark for 90 pence. Okay, question 2. Rob has carried out a survey. He asked 25 students how many times they visited the library last month. His results are shown below. Using Rob results, answer the following questions. What is the range? Now, many of you will know from experience that whenever I'm presented with a table, the first thing I want to do is to choose a column in the table and make sense of the context. So in this case, well, let's just check what my tally marks are saying here. That one is tallying as 6. That one is tallying as 7, 4, 8, 0, 0. So this column is telling me that 7 students visited the library on 2 occasions. 4 students visited the library on 3 occasions, and so on. The range is the largest number of visits, take away the smallest number of visits. It's not the largest number there and the smallest number there. It's with the data, the range. So the range in this case is 4 take away 1. The most people visited was 4 times. And the least people visited was once. So the range is 3. So the circle for that is 3. Second question, what is the median? Well, the median is the middle value in an ordered list. Well, the list is in order here because it's been grouped. If I wanted to, and if you felt you needed to, you could write this as no zeros, 6 ones, 1, 2, 3, 4, 5, 6, 7 twos, 4 threes, and 8 fours. So the list is in order, and we're looking for the middle value. So if there are 25, the middle is going to be the 13th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's your median, 2. But you don't need to write it as a list because it's already in order. So the first 6 take you to that point. The next 7, so the first 13, take you to that point. So the 13th is in that group, so it's 2. Okay? You should be able to deal with that, but if you would prefer to write the whole list out, then do so. 1 mark for each of those. Part B. Rob put some books and a weight on a set of balance scales. All the books are identical. That's important. Question, what is the mass of 1 book? So it's balancing on a scale, and each of those books are identical in mass. So that means I can pull those 2 off there. So long as I pull 2 off there, it will still balance because they weigh the same. That will mean that I'm balancing 1, 2, 3, 4, 5 books against 1,750. So 5 of the books weigh 1750. So to find one book, I have to divide by 5. Non-calculator paper, so I need to have that skill that I can divide without a calculator. 5 goes into 1, it doesn't. So we go 5 into 17, 3 times, remainder 2. 5 goes into 25, 5 times, and 5 goes into 0, 0. So one book is 350 grams. So this is the way, back in Key Stage 3, you would first met equations. Part C. Rob balances some identical dictionaries. 10 dictionaries are on one side, 2 dictionaries and a 3,200 weight are on the other side. Let the mass of one dictionary be X grams. Use the information to write an equation in terms of X. So this time, they've taken the picture away. But they're telling me that 10 dictionaries are on one side, and each of those weighs X grams. So 10X is going to be on one side of the balance, and that's going to balance against 2 books and a 3,200 gram weight. So that's what your equation is going to look like. Find the total mass of all 12 dictionaries. So with an equation or with a balance, what you do to one side, you have to do the same to the other. So just like I took 2 books there off each side, here I'm going to take 2x off each side. So if I'm taking 2x off both sides, on this side I'm left with 8x, and on this side the 2x's have gone, so I'm just left with 3,200. To get the x on its own, I have to divide by 8, because the 8 and the x are joined by a multiply, which means I have to divide that side by 8 as well. That leaves me x equals, and 8 into 32 goes 4 times, so 4 8 to 32, followed by 2 zeros. So 400 What have I done wrong there, guys? Haven't read the question. I've worked out the weight of one book. The question wants all 12. So I have to times it by 12. 4 12s are 36. So the mass of all 12 dictionaries is 3,600. So a great example there. I won't pretend it was deliberate, to read the questions carefully. So marks for that one. 1 mark for 5 books weigh 1750, however you want to write it, and 1 mark for the 350 grams. 1 mark for the equation, and then a method mark for solving the equation, and an answer mark for the 12 books at the end. Okay, question 3. So straight away, here's our OCW question. This is the one we have to think carefully about how we lay out our work. Treff Tiles sells boxes of small wall tiles. 3 different boxes are available. A box of 25 tiles, which costs £7.50. A box of 40 tiles, which cost £11.20. and a box of 100 that costs £29. Catherine is buying a very large quantity of these small tiles to cover all the walls in her bathroom. Which box offers the best value for money? So that's what my conclusion needs to be down here. In order to find value for money, I have to compare equal quantities. You don't look at the difference between them and say, well, you get this many more for this many more tiles. You want to say something like, well, 10 tiles there will cost something, whereas 10 tiles here costs something else, and 10 of those, and then compare those prices. Now, when I look at the numbers here, I think that it's going to be the easiest thing to do to work out the box, how much it would cost for 100 of these tiles, which I can compare with that, and 100 of these tiles, which I can compare with that, rather than finding the cost of one tile, which will be a really small number. So if I work with this one first of all, so for the box of 25 tiles, 100 tiles, well, that's going to be 4 boxes. So it's going to be 4 lots of £7.50. Well, doubling £7.50 is £15. Doubling it again would be £30. So 100 tiles, if I'm buying in boxes of 25, will cost me £30. For the 40 tiles, to work out 100 of those, I'm going to need 2 boxes, which will be £11.20 plus £11.20, plus another 20 tiles, which is going to be half that cost. Which will be £6.60. And add those together. So 100 tiles will cost £29. And then the other one, we've already got 100 tiles. Okay, what have I done wrong? Yeah. Is this 560? Yes. Wonder what I've done wrong. So naught, so that is then going to be £28. Thank you. No, that's still going to be £29. That's £28. So if I buy 100 tiles using 25 tiles a box, it's going to cost me £30. If I buy 100 tiles that come in boxes of 40, it's going to cost me £28. And a 100 tile box is going to cost me £29. So the best value for money is actually the box of 40 tiles. Now, what you've got to think here is you may be thinking, well, hang on a minute, but you can't buy half a box. I don't want to buy 100 tiles. I just want to compare how much 100 tiles would cost on each of them. So that's why we're working it out that way. So the best value for money is going to be the 40 tile boxes. Okay? So the marks for that, there's a method mark for just working, trying to find all the same amount. So whether you're working with 10 tiles for each of them or 100 tiles, it's usually easier if you can turn 2 of them into the third, because then you haven't got 3 lots of maths to do. You're only working with 2. So there's one method for trying to do that. There's 2 marks for getting all of those correct. So I'd have lost a mark there. And an explanation mark for your conclusion of which is the best value for money. And then the 2 OCW marks. 1 mark is for organising your work, so just writing a statement about what each line of maths is about will get you 1. And then the second is for consistent use of units. So in this case, the pound sign wherever I'm talking about money, and tiles when I'm talking about tiles. So it's not a story writing competition. Part B. Trev Tiles sells a wall tile measuring 10 centimetres by 20 centimetres. How many of these tiles would be needed to cover a wall measuring 3 metres by 4 metres? You can assume there are no gaps between the tiles. Okay, whenever I'm working with things like this, I like to do a little diagram. So here I've got a 10 centimetre by 20 centimetre tile, and I want to find out how many of those are going to fit on a 3 metre by 4 metre wall. So I want to see how many 10 centimetres fit that way, and how many 20 centimetres are going to fit that way. Before I do that, I need to have everything in the same units. So I'm working with centimetres there and metres here. I know there are 100 centimetres in a metre, so it's going to be much easier for me in this case to be working in centimetres. So now I want to see how many 10 centimetres fit in to 300 centimetres. So in that direction, it's 300 divided by 10, which is 30 tiles. In this direction, it's 400 divided by 20, which is 20 tiles. So I need 30 tiles to fit across, 20 tiles to fill down. So across the whole thing, I need 20 times 30 tiles. 2 3s are 6, followed by 2 zeros. I need 600 tiles. Marks for that. There's 2 marks if you know you need 30 tiles and 20 tiles, and 1 mark for getting the correct number of tiles. Part C. Trev Tiles has 5 boxes of tiles on special offer. All the tiles in each box are identical. So box A is full of square tiles, B rhombus, and so on. 3 of these boxes contain tiles that tessellate. Manon is asked to select these 3 boxes. Which 3 boxes should he select? So tessellation means that if you put a number of those together, they will all fit perfectly to cover around a point. So if you look at the tiles on the floor, which are rectangles, they tessellate because there are no gaps. So a square will tessellate. Yeah, if I draw squares, they're going to tessellate. So box A will tessellate. A rhombus is a squashed square. It's a square that looks like that. They also tessellate. A regular pentagon you're not going to be sure about, so we'll wait about that. A circle we know will not tessellate because you're always going to have these gaps. But if we think about a right angle triangle is part of a square or a rectangle. And for every one of them, we can turn it around and have it going the other way. So even though I wasn't sure about a pentagon, the question's telling me there are 3 of them, and I know that a right angle triangle will. So even though I'm not sure about a pentagon, I'm not going to choose it. And there's 2 marks for getting all of those right, or 1 mark for getting 2 of them right. Question 4. The mass of rubbish recycled is given as a percentage of the total mass of rubbish produced. The percentage of rubbish recycled by people living in 8 small towns was recorded. The results for the first week in July 2005 are shown in the scatter diagram below. Now, part of the advantage of doing lots of these papers is you see things that come up more than once. We had a question on last night's paper to do with a child's mobile phone bill. Exactly the same question as this, but in a different context. Complete each of the statements below. In July 2005, 2 of the 8 towns had the same number of people. The percentage of rubbish recycled in these 2 towns were. So the same number of people. This is my number of people axis. So I'm looking to see which one of these has got more than 1 dot in. So 2,000, there's only 1. 3,000, only 1. I'm looking for where there is more than 1 dot, and it's here. It's these 2. So I've worked out where I am. The percentages of rubbish recycled in these 2 towns are, that's this axis, so I'm reading across, it's going to be 10% for one of them, and 40% for the other. The town with the least number of people, so where are the fewest people, had a set target recycling 45%. This small town beat this target by blank. So the least number of people is going to be 1,000, but there aren't any. 2,000 has got 1. So that's the dot I'm interested in. They actually achieved 50%. Their target was 45%. So they beat it by 5%. So it's important you read carefully what the axes are telling you. Marks for that, easy, 1 for each of those. Part B. Explain why it is not reasonable to use this data to estimate the percentage of rubbish recorded in a town of 9,000 people. So 9,000 people is off the scale. If you had a scatter graph that showed a correlation, showed a relationship, then you could draw a line of best fit and read off it. But this one hasn't got any correlation. There's no upward pattern there or downward pattern. So it's not reasonable because there's no correlation. And you'll get 1 mark for the explanation. You could also say that there aren't that many towns there. So that's the nice mathsy answer, but you could talk about it in context. There are no other towns that size to compare with, or something like that. In 2016, Merriford Town Council recorded the total mass of rubbish recycled. Of this mass, 130,230 tonnes of paper, was paper and cardboard. This amount of paper and cardboard was a quarter of the total mass of rubbish recycled. So a quarter of the total is 130,230. And what we want is the total. Now it might help you to think about this as a little diagram. Okay, so let's draw ourselves a little pie chart. What we're saying is if that was divided into quarters, each quarter would have that amount in it. So if you want to find out the total mass, you've got 4 lots of that. So what we're actually doing to answer that question is timesing that by 4. 4 zeros, 0. 4 threes are 12, 2 down, carry 1. 4 twos are 8, and the carry 9. 4 zeros are 0, 4 threes are 12, 1 4 is 4, and the carry 5. So the total mass of rubbish recycled is 520,920 tons. So if you get in a bit of a knot with fractions, just draw yourself a little diagram. And the 2 marks for that. There's a method for timesing by 4. And so long as you don't mess up the timesing, you get your A answer mark for that value. James? Sorry? Have I? No, that's right. Oh, down there. Sorry, yes. Yeah, okay. Been a long week. Yeah, so those are 130230. And that one would be the same, James? Yeah, that's the same, and that's the same. We'd have 4 of them, yeah? Thank you. Okay, question 5. A badge is made using a metal button, a pin and a sticky tape. Lulu's craft shop. So we got some information there about the buttons, pins and sticky tape. Elwyn decides to buy metal buttons and pins to make badges so that there are no metal buttons or pins left over. He wants to buy the least possible number of packs of buttons and bags of pins. Show that Elwyn should buy 4 packs of metal buttons and 7 bags of pins. Okay, so what we need to do here is, in order to make the badges, I need to have the same number of buttons as pins. And because they're in different packs, they're going to multiply up for different numbers. And what you're looking for is to end up with a number of packs to get the same number of buttons as you've got pins. So if we look at buttons, 1 pack of buttons has 42. 2 packs of buttons has 2 lots of 42, which is 84. 3 packs of buttons is going to have 126. Now we could keep that list going, but let's do the same for the pins. Pins are going up in 24, so 1 pack will have 24, 2 packs will have 48, 3 packs will have 72. Okay, so I'm not there yet, so I need to go to 4 packs, or here first. So 4 packs is going to have another 24. So that's going to be another 24 in there. So 696. 5 packs, another 24. So we're going to have 120, which is getting close, but not close enough. 6 packs, 120 plus another 24 is 142. No. 144. So if I add another 42 to this one, I get 861. So that's 168. I need to add another 24 to this, which would be 7 packs, and I'll get 168. So 4 packs of buttons and 7 packs of pins gives you the same total that you need. So 4 packs of buttons and 7 packs of pins have the same amounts. What's the maximum number of badges Elwyn can possibly make using 4 packs of buttons and 7 packs of pins? Well, 168. Because we've done all the work up there. So for that, there's 1 mark for showing that you're working with multiples of both, and 1 mark for getting to the right answer, and 1 mark for getting the 168. Okay, so what you're actually doing there is finding the lowest common multiple between the 2 different numbers. Part B. Each pin is stuck onto a metal button using approximately 2.5 centimeters of sticky tape. Elwyn plans to sell the badges to make the maximum profit possible. How many rolls of sticky tape should Elwyn buy? So, he's buying 168, or he wants to sell 168 badges. So I know that each roll of sticky tape has got 60 centimeters in it. So I can now work out how many strips or how many badges 1 roll will cover. So I want to see how many times 2.5 fits into 60. Using whatever method works for you. Okay? Now, I know that 5 goes into 25, and I know that 5 goes into 60. So 5 goes into 25 5 times, so it's going to go into 2.5 0.5 times. And it goes into 60 12 times. And how many halves are there in 12? Well, there's 2 halves in 1. So what you end up doing is doubling, or another way of thinking about that is 12 over 0.5 is the same as 120 over 5 by timesing both of those by 10. There's lots of different ways of doing that. You just need to be clear how you are going to do a division of 60 divided by 2.5. So what I'm actually doing is how many times does 5 go into 120? So 5 goes into 12 twice, remainder 2, and into 24 times. So they're going to need 24 sorry, they're not going to need 24. So 24 buttons can be made per roll, and I want to make 168 buttons. So now I've got to work out how many So I've actually now got to do 168 divided by 24. Using whatever method works for you. They're both even, so I can divide by 2. When I divide that by 2, I get 84. When I divide that by 2, I get 12. I can divide both of those by 2. 42, 6. And I know 7 6s are 42. So that's going to be 7 rolls of tape. So there's some nasty division going on there. If you're not strong with your non-calculator multiplication division, that's something that you'll have found quite challenging. And the marks for that, there's 1 mark for working out something like how many buttons per roll, and there's 1 mark then for dividing that into the buttons, and 1 mark for the answer. Second part, Elwyn sells all the badges he makes for 50 pence each. Calculate the maximum profit he would make. So if he's selling them for 50 pence each, his income is going to be 168 badges times 50 pence. Okay, so that's 160 lots of £0.50, which will be £80. Now, what do they cost him to make? Well, he's buying 4 packs of buttons, so 4 lots of £2.50. Four lots of £2.50. 2 lots of £2.50 is a £5, so 4 lots will be £10. And he's also paying 7. Pins, which cost £1.10. He's buying 7 packs of pins, which would be £7.70, and 7 rolls of sticky tape at 52 pence each. So 7, can't do that one in my head. 7 2s are 14, 7 5s are 35, and 1 36. So they'll come to £3.64. So his total outgoings will be £10 plus 17.70 plus, £10 plus 7.70 is £17.70 plus another £3.64. So 17.70 plus £3.64 is £21.34. So his profit is going to be the difference between what he made that should be 168, shouldn't it? So that should be 84. So it's the difference between the £84 that he made and the £21.34 that it cost him to make them. Okay, so the profit, I need to make space for, it's going to be £84 less £21.34. So you've got a non-calculated method now to count from that to that, or lay it out as a full subtraction. So if we're subtracting that, we need to borrow from there to make that 9, and we've borrowed from there, so we get 6, 6, 2, 6. £62.66 is the profit. So there's a lot of maths going on there, but it's worth 5 marks. So there's 1 mark for the £84. There's 1 mark for working out the various parts of the total costs, and an answer mark for the £21.34. And then your final mark is for the profit. So we've got 1, 2, 3, 4, 5 marks there. Okay, so we've got 1 question left from the foundation overlap. So question 6. Mould is on a bearing of 065 degrees from rough-in. What is the bearing of rough-in from mould? So I got a bearings question with no diagram. Now, you might want to draw a little diagram to help you here, and on the back of your exam paper you've got additional space if you need it. So I would certainly here be thinking, right, mould is on a bearing of 065 degrees from rough-in. So if I draw myself a little diagram, there's rough-in. I've revised bearings, so I know what I'm doing. From north, to get to mould, I'm going to turn through about 65 degrees, which I know is an acute angle. So that's going to take me to mould. And what I want to know, or what I need to know, is the bearing of rough-in from mould. So now I'm standing there, and I need to find out what that angle is. So there's nothing stopping you with this question actually drawing that yourself using a protractor. It's not the way they want you to use it. What they want you to do is to think parallel lines, because your north-souths are parallel lines. And within that, you can see here, you've got the alternate angle, the Z angle, which means if that's 65, this is 65 here too. So the angle that I want is 65 plus the 180 from north to south. So I got 180 plus the 65, 5, 15, 255 degrees. So the angle I'm looking for there isn't there, so I've added that up wrong. 245. Okay, so it's 245 degrees. Part B. Rill is on a bearing of 330 degrees from rough-in. So I got a second one to do here. So on the back page, I'd be doing another little sketch now. Here's rough-in. On a bearing of 330 degrees. Well, 330 degrees is going to take me right the way round that way. So rill is up there somewhere. All of that is 330, which means that there is 60. Now I want to know the bearing of rough-in from rill. So I'm now up here with north, and I want that angle there. Well, if that is 60, I've got a Z angle, which makes that 60. Then you're on a straight line. So take 60 from 180, leaves you with 100, and it's not 60, it's 30. So that's 30, so that's 150. Because that has to add up to 360. So that one is 150 degrees. Then we've got a couple of time questions. We did this in Reg yesterday morning. When it is 1940 in Cardiff, it is 23:40 in Dubai because of the time zones. What time is it in Dubai when it is 13:30 in Cardiff? So what we need to do is work out what the difference is in the time. So the time difference, so we're going from 1940, and just counting on your fingers, 1940, 2040, 21, 22, 23. There's a 4-hour time difference. So when it's 13:30 in Cardiff, it's going to be 4 hours later in Dubai, which is going to be 17:30. What time is it in Cardiff when it is 2:10 in Dubai? So it's going to be 4 hours earlier than that in Cardiff. So 2 hours earlier will take you to 10 past midnight. 2 hours before that will be 10 past 10. So 22:10. So they've mixed up there a couple of bearings questions and a couple of time zone questions. Okay, and that takes us to the end of the foundation tier section. So we'll take a break there.